Okay, we're going to go over a little intro to LaserCut, which is the software that you will use to prepare and maybe design and send files over to the laser for engraving or cutting. And just before we get started here, I do want to point out some important things here. If you go to the Make It Labs wiki, which is wiki.makeitlabs.com, you can scroll down here on the left side to under Resource Areas, Laser Cutters, and then, sorry, Laser Rabbit. So if you click on Laser Rabbit, you'll get most of the information and some training material, documentation, etc. on the Rabbit, which is the big 80-watt laser that we're training on right now. But I also do want to point out that if you expand under this Laser Rabbit, there is this link here using LaserCut 5.3 elsewhere. And this is a link that I want you to go to right now, and it will tell you how you can install the LaserCut software at home. And when you do, you can even play around with it, learn it, and most importantly, follow along yourself with this little tutorial that I'm giving. So I highly encourage you to do that uh, right now. You can pause and install that. If you can get it running, that's good. And also, I want to point out before we get started with LaserCut, that LaserCut is not the greatest design program in the face of the planet. It's good for prepping files that you need to send to the laser. It's good for some laser specific stuff, but it's not a general good design tool. So also under this Rabbit Laser section, I have a section on laser design software. And this is software you could use to design. And there's kind of two different categories of it. There is vector drawing programs. These are programs like Inkscape or Illustrator, which are kind of more artistic in nature and allow you to generate vector drawings. And then there's CAD programs like SketchUp or AutoCAD or Fusion 360 that are a little bit more engineering and precision geometry oriented. Granted, there's a lot of overlap between those two categories. But if you don't know any of these tools, basically any kind of CAD or vector drawing program, really anything that can generate a DXF file, I highly encourage you to go learn one. Inkscape is a great open source free one for vector drawing, and there's a lot of other ones like FreeCAD, Fusion 360, which are also free CAD programs. So I highly encourage you to check one of those out. So assuming that you know that, or you've done that, or you've done something to generate a DXF file that you now want to cut on the laser, let's go over and launch LaserCut, and we will get into that. Okay, so now we're in LaserCut 5.3, and this is launched by clicking on the appropriate icon, which we keep docked in the toolbar. It's this little blue and white snowflake looking icon, and that brings up the program here. So you can see the initial GUI and is basically this main window with this rectangle right here represents the laser bed as you would view it looking straight down at the laser. So this is the closest left corner of the laser and the furthest to the right corner of the laser. These measurements here are actually in centimeters, but I'll tell you right now, this is the last time we'll see centimeters or any other units used in this program. Everything else is done exclusively in millimeters. So for this first flow right here, we are just going to not do any design in the program. You can do basic designs in the program, but any real work you're going to do, you're going to be designing in another program, as I mentioned before, and you're going to basically save your file as a DXF, and you're going to import it into LaserCut as a DXF. So we're going to go File, Import, and I made this little person file, and I generated this in Inkscape, and I'm going to hit Open, and it is going to come up. Now notice that time it came up. A lot of times you can get some erratic behavior in LaserCut where you go to import and either, like right now, oh, there we go. Sometimes you won't get a preview. Sometimes you'll actually get an error when you click on something and preview it. Sometimes it'll preview it and then you'll hit open and then you'll get an error actually opening it. The best thing I can advocate that you do is to close LaserCut, relaunch it, and then try File Import again, and it'll usually work the second or third or fourth time, but it eventually will work. Sometimes people do crazy things like they can click previews of different files, and then when they go back to the first one and then try to open it, it opens okay. your mileage may vary. You might have to try it a couple times, you might have to quit and relaunch, but eventually, if it is a well-formed DXF, then you should be able to import it. That said, like, I don't know how much you've worked with DXF files, but sometimes newer formats can have weird types of geometries in them, which this program could have problems with. We don't see that too much, but you can always play around and save it. And sometimes you can save it in an older DXF format, or you can simplify it in certain ways. But that's all very dependent on how the DXF export in the program you're originating your artwork works. So anyways, file open your DXF, and it should import it. Now, couple important things to note as we just opened it. Number one, notice that it zoomed way in on the work table, so we don't really have a good intuitive understanding of what the dimensions of this are. And sometimes, due to problems both in LaserCut and problems in the DXF exporter and other things, dimensions can get all messed up. You think you exported a thing that was 6 inches by 6 inches, it brought it in as 6 millimeters by 6 millimeters, or vice versa. So one of the first things that you always want to do when you import a file here is to check the size of it. We can do that. First of all, I'll tell you that there are some basic tools up here. We can zoom out and we can zoom in. That isn't, oh yeah, that little. So anyways, these tools are a little wonky. You can see this is zoomed out when I clicked it, but when I zoomed in, it just gave me a magnifying glass and made me click it. A little strange. The hand, which is like a pan tool, it's kind of strange too. When you click and drag, it draws a line. Then when you release, it kind of pans to that line. My advice here for zooming and panning is to just use your center mouse button. So center mouse button down is going to zoom out. Center mouse button up is going to zoom in. And if you want to pan, I personally find the easiest way to do is to zoom out, put the mouse where you want to zoom into, and then just, again, mouse wheel zoom in. And that, for me, is the easiest way to pan. Zoom out, mouse, zoom in, rather than dealing with some of these, wonky zoom and pan buttons. There are a couple other, this one will zoom to the entire surface of the table, like you can see here. This one will zoom to just your artwork. I don't want to totally run down the whole GUI, but I'll just run through some of the big important things as we come to them. The most important tool in the GUI is this one right here, and they call it the pick tool. It's sort of like a pointer, and it is used to select and deselect. So if I just clicked out of this, it deselected. If I click on a geometry, it lights up. If I click on a different geometry, it lights up that one or selects it and deselects the other one. If I shift click two of them, you'll see it selects both of them because they're both now red, and it always puts this X in the center. The importance of the X in the center is if you want to drag and move something, you have to drag and move on the X. And you'll notice when I get over to the X, the cursor changes to that move. If I try to move here, it's actually not moving. It's just giving me like a selection bounding box. So you can drag select, obviously, to select things, or you can individually click on them. Like I said, they turn red and give you the X as the center of it. I could select this whole face, and if I wanted to move the face again, drag over or hover over that X in the center, and then you can move it as such. Control Z to undo. You can also do kind of a wonky resize by grabbing one of these corner handles, clicking them, and moving. I'm going to undo that. If you want to constrain, you can control, click, and drag, and that'll give you a perfectly constrained X and Y coordinates to that. And that is good for that. So like I said, we just brought, so that's just some basic selection and basic resizing, and we'll get more into that. So as we said, when we bring in a piece of artwork in, the first thing we want to do is to check the size of it to make sure it is okay. And in this particular case, I drew this file in Inkscape, and if I look at that guy in Inkscape right now, I can click on Inkscape. You might not be familiar with it, but I can see, okay, width and height, this guy is about 81 millimeters wide and 80 high. So let's see what it actually pulled in as. So I can do that by selecting this whole guy here, or I can Control A to select everything. And this icon over here on the left side is the size tool. I can also get that by hitting Control G. And when I hit the size tool and I have the entire thing selected, it tells me what this thinks its size is. And as you can see right here, it thinks it's 80 by 79, which is about what Inkscape said. The little variation I'll just mention is because Inkscape, I gave it a little bit of a line width, so it's including the width of the lines in that. Whereas in LaserCut, that's actually, there's no line width. So 80 by 79, say this was totally wrong, say, oh, this is really supposed to be, I don't know, 160 by 280. I can go 160 by 280 and do that. Again, these are in millimeters. If I wanted to, I'm going to hit cancel now. I'm going to go back into that. If I wanted to do this in inches, I would have to do a manual conversion. If I wanted to scale it by a certain number of percentage, I would need to get out a calculator and do the math for that. There is one little way that you can do a constraint. Say I knew that, oh, the X was supposed to, this whole thing was supposed to be twice as much. I can sort of do a constrained resize. But I would have to do the exact math, but I could put a number here in. And when I have that number here, if I click on one of these little dot things, it will basically scale this proportionally to the other one. So I doubled that 80 about. So when I hit this, it's going to scale that proportionally as well. And when I hit OK, it doubled the size. So that's, so again, everything is in millimeters. Anything but millimeters, you're going to have to do manual math, but you can modify one of these and then hit the ellipsis there to get a constrained resize. This came in okay. My advice, because this gets messed up a lot, you will go to pull some artwork in and the artwork won't be the right size. And so you can do what I just did, which is, get it from your original program, find out what the height and width is in millimeters, and then, pull up your resize tool over here and type those numbers in. What I will do a lot of times is I will do something like I'll draw a, in fact, we can do it right now just for fun. I will draw a box here in Inkscape, and I'm going to size this box to be exactly 100 by 100 millimeters. And then I'm going to surround this guy in this box, and I'm going to export this file, and I'm going to call it person, and I'm going to say 100x100, and I'm going to save it as a DXF file. In this case, when you use Inkscape, I'll tell you always use base units of millimeters. I don't really know what these things do, but we generally check the first one and not the last one. And this is what I was telling you about weird different options for different DXF options that your program that you're exporting in might do it. But definitely always save it in millimeter base units, and that's correct. So I'm going to save that there. Now I'm going to go in here. Let me select this guy. I'm going to hit the delete key and delete him. And I'm going to do File, Import. And again, now I have my person 100 by 100. It actually shows up when I clicked it. And when I hit Open, so I get the person with the bounding box. And now if I, again, select the whole thing and I hit Size over here, it's saying, wow, it came in as 100 by 100. But let's say like it did something totally wonky. It came in at 452 by 452. And, I opened it up and, it looked like that. And I said, wait a minute, that's not right. It's supposed to be 100 by 100. Since I have this 100 by 100 bounding box around it, I don't need to copy numbers in. I just type in 100, 100, rescales the whole thing. And now when I delete this bounding box, so I'm clicking each of these and hitting the delete button, and then I can select this, and when I hit size on this, it's that 80 by 79 thing, which is a close approximation to, what this guy was supposed to have come in at. So that's kind of, I'd say, a best practice for assuring and checking that things are going to come in at the right size when you bring them in. So basically, that's step one when you import a DXF in here. Step two is if you'll notice that we have all these, I'll zoom in a little bit, we have all these little yellow dots and these little red arrows, and these kind of represent the different pieces of geometry in the DXF file. And in this case, even though the way we saw it in Inkscape over here is we saw these things as, you know, giant single geometries, when we exported as DXF, it saw each of these as individual pieces. And the way that it's going to cut these, it's going to cut them as individual pieces, and you don't even necessarily know what the order is. So there's a tool that we can use to fix this, because this happens all the time when we bring things in, and it is called Unite Lines, and it's under the Tools menu. So Unite Lines basically says, hey, if I have any 2 points in this file that are within a certain tolerance, just merge them together. So I'm going to use Unite Lines, and Unite Lines, again, this is millimeters, but usually in our case, these lines should actually be in the same spot, even though they're not connected together, so it thinks they're different geometries. So the tolerance doesn't matter so much, but when I hit OK, we will find, now if you look at this guy, we have one yellow dot on this thing. When I click on it, it doesn't break it up into a whole bunch of different ones. It selects the entire thing. So this body is one geometry, these eyes are one geometry, and this face or the smile is one geometry. So that's what we want. So this is going to be one cut path, another, 3 cut paths for the entire thing, rather than like a whole bunch of different individual ones that we saw over here. I just undid that, but I'm going to reunite it. So that is how we bring in a DXF. We make sure the lines are united. We make sure the scale is okay. Now, the other thing that we're going to get into is, depending on the order that you're watching this video in, you might have been told about materials, and depending on the thickness of the material, and if we're cutting and engraving, and the type of material, we need different settings for the laser. And the settings, you know, for cutting are the speed that the laser head will move and the power that the laser will physically cut at. Those, we're going to look them up in the manual or look them up in the wiki if you don't already know. And it's up here that we set those things. So up here I can double click, and this is giving me stuff for speed and power. And so maybe I looked up in my manual. In fact, we can look on the wiki right now. If I go under, again, Rabbit Laser page, and by the way, this is the page that, actually, is that the page? That is not the page. It's one of these pages that come up when you open the web browser on the Laser PC. It is, this right here is the page that it automatically opens to, and it is laser settings 80 watt, because the Rabbit, or our Rabbit, is an 80 watt laser. And when you open this page, this is what you'll come to when you open a web browser on the Laser PC. You'll get this table, and this table is giving you a reference, a basis of the settings that you'll want to use for a multitude of different materials and different thicknesses of those materials. So first off, you want to know if you're cutting or you're engraving, and the difference is cutting blasts right through a material all the way to the outside, whereas engraving just kind of engraves or etches the surface. So with engraving, we don't really care how thick the material is, because we're inherently always doing the surface. Within cutting, we do care about the thickness of the material. So when you see here all mode cut, it has thickness inches specified, whereas when I scroll down under engrave, it doesn't really matter what the thickness is. But when I have and again, this is just an idea, but I can say, well, it's wood. What kind of wood? Basswood, plywood, birch wood, whatever. Birch plywood, 0.1888 inches. This is like 5 millimeter. This is like the kind of, most of the stuff on the rack, the wood you'll see is about 5 millimeter, and it's usually some sort of plywood. So for example, this says I would use a 70 watt or 70%, not 70 watt, but 70% is the power, and 10 millimeters per second is the speed. So if I had in fact had like 0.188 birch plywood, this is the kind of setting I would use for that. 70 is my power, and 10 is my speed. So again, going back into LaserCut, I would say, what did I say? I said speed would be 10 and power would be 70. And if I hit OK, that is what changes up here. So that means this is going to run at, is that really what it said? Sorry, I messed that up. Speed is 10, power is 70. There we go. I will note, and again, I don't want to get too into corner power is another thing that basically probably discuss in person when we talk about materials. When you're cutting, like let's look, for example, right here, this little groove, this little piece of the neck. So if you picture what the laser is going to do when it cuts, it's going to come down, 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 down at its speed, which is, what do we say, it was 10, and it's going to hit this point, and then it's going to start to come off this way. So when it does that, it's going to basically kind of inherently stop to change direction. So if I have a certain amount of power that's cutting, 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 I stop here for a second, and then cut, 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 you might get a little burn artifact because I'm essentially stopping with the same amount of power, so it's going to char it a little bit more. And if you look at a lot of the pieces on the rack, particularly pieces that are wood, and you look in sharp corners here, you might see a little bit of a char. And if that's something that's really not working for you, then you can adjust this corner power. You can turn it down a little bit, and that might solve the problem. And if the opposite happens, if you have some material where, I don't know, for whatever reason, it's not going all the way through in a corner, you're getting a little problem, you can turn the power above the regular power setting. But normally, corner power and power can be set about the same. And that is about the setting. So now, if basically that is the workflow, and we took a lot of time to discuss it. But again, it's import the DXF, make sure the size is correct, make sure the lines are united, set the speed and power, and then from this point, if I was actually connected to the laser, which I'm not because I'm also running at home, I would just hit download, and then when you hit download, see, it's not going to work here because I'm at home. Yeah, see, I can't talk to the laser. Oh, yes, so this is what it would do. When you hit download, the way the laser actually works is technically it stores files on the laser, and it runs them from the laser, but we don't care about that. So we hit download. The first thing we do is we hit delete all. It deletes everything on the laser. We hit download current, and that'll send it to the laser, and you'll see it counting down with a little progress bar, and then the name of your file will show up on the laser. And then when that's done, we just hit close. And at that point, the file is on the laser, and we can then, and we'll have to show this in person or in a different video, we can hit test to trace the bounding box, and then we hit go to actually burn the project. So let's talk for a second about what the bounding box is. So if I have a project I want to cut in the laser, and let's say it is a star, a bounding box is simply a box which encompasses the geometry of the star like this. And that's important because when we take that project with, let's say, the star, we go to put it on the laser, one of the first things we do is we press the test button. And what the test button does is when we press it, it traces that bounding box with the laser off. And the important thing about that is that when we actually go to put a project on here, we can't actually see where the star is and we can't see where the bounding box is. So having the ability to hit the test button and have the laser trace that bounding box tells us a couple things. It tells us where we think that image is going to be on the laser bed. It tells us how big we think it should be, and it tells us the orientation from which that will be cut. You know, for example, in this case, that bounding box is starting at the upper left from where the laser is. So that's basically it. So again, it's download, delete all. Download is going to take a second to time out because I'm not actually talking to the laser right now. So it's download, delete all, download current. And that is how to send a thing to the laser. And then usually the first thing you do is hit the test button on the laser to trace the bounding box. So that brings me to one other point. So if the laser, like we were looking at the laser right now, which we can't, and the laser head was here, and I were to hit test, it traces the bounding box of the artwork that you're cutting. So in this case, this blue dot here refers to the origin of the art you are cutting. So in this case, this blue dot means when I start cutting, I want the laser, because it's going to cut relative to where the position is right now. And that's in fact what this immediate checkbox means. Again, the immediate checkbox means when I hit go, the laser is going to start cutting relative to wherever it happens to be on the bed at that point in time. And this blue dot means basically consider that the laser is starting in the upper right-hand corner of the artwork. So when I actually hit go, or rather hit test, it's going to start tracing to the left and down. If I didn't like that, let's say I had a piece of something in there and I wanted to start like the piece looked physically like this, and I wanted to start it in the upper left-hand corner up here, I can go into laser, set laser origin, and I can say I want you to cut this relative to the top left. And notice when I do that, it immediately moved this that blue dot to the upper left, which means now if I did download, delete all, download, and I hit test again, rather than that bounding box starting to trace to the left and then down, it would go to the right and then down. So it's going to cut as if the artwork is supposed to be to the right and down of where the laser is. So that's something to be cognizant of. It's always important that you, when your first thing you do is when you download it to the laser, you hit test to make sure that, A, it's the correct size that you think it's really going to cut. B, it's not crashing into anything. C, the image is really entirely on the bed. You didn't have a big piece and you thought that the laser was going to go up, and instead the laser wanted to go down. And you'll get you'll get like a soft stop error if the laser thinks it would have to move the laser off the laser bed in order to cut it, in which case you'd need to do something like reposition where the laser is to start or change the origin for that. So here's another thing. Say, for example, we wanted to do something weird, like we wanted to do the eyes at a different power than the rest of the body, or let's say we wanted to actually engrave the eyes in the mouth rather than cut them. So we want to engrave the eyes in the mouth, and then we wanted to cut the body. So just in case you don't know, so when we cut with the laser traces these paths and uses a lot of power, blasts entirely through the material to free it from the original material. When we engrave, what happens is the laser moves back and forth really fast and sort of draws it raster, line by line, energizing the laser as it crosses into like the inside of the circle or the inside of the mouth. So, that will just mark the surface. So that's something the laser can do too. I'm not going to get very much into engraving on here other than just tell you how to set it up right now and to explain what I did. There is another video online I encourage you to take if you want to do more with engraving or you want to engrave bitmaps. Please go watch that video. And if you want to do really, really, really fine stuff, we have the other laser, which is the full spectrum, which has a lot of software that helps automate doing really good bitmap engraving as well. But so here's just the basics of engraving. What you need to know here is, say, for instance, so like I said, I want to cut the black outline of the body and I want to engrave the eyes in the mouth. So what I can do here is I can click the eye and I'm going to say I'm going to make it blue. And I make this eye blue. I'm going to make this eye blue. And if you notice when I started adding blue geometry to here, this thing over here turned blue. And so as you can probably infer, that different colors here in the GUI are going to allow me to apply different settings to them. So in this case, this blue, I don't want to be cut mode, I want to be engrave mode. And what kind of settings do I need to do to engrave? Well, like I said before, we can go to the wiki, and engrave settings are a little bit simpler than cut settings because we don't have to worry about the thickness at all. So for instance, like with wood, there's like only one setting, whereas with cutting, different thicknesses each have their setting. So because it's zipping back and forth very fast, engrave speeds are generally much, much, much higher than cut speeds. So for instance, where did it say? Wood, 350 is the speed and 14 was the engrave. So I can go, again, double click on here and I can set speed to 350 and engrave to, power to 14. Scan gap, I'm not even going to get into. The other video on engraving, explains scan gap in excruciating detail, so I encourage you to watch that. So a couple other things that are important that I will show you right now. Number one, say for instance we said, oh, so what I really want to do is, because when I cut all the way through and then the piece gets to the point where the last piece cuts and it separates, it could actually shift. It could drop onto the bed if it's elevated, or it could just detach and move. So what I really want to do is I really want to make sure I've done my engrave first and then do my cut. I can do that by adjusting the order of these two up here. So you see it says cut is first and engrave is second. That means right now it's going to cut first and engrave second. I don't want to do that. So I can select one or the other and then use these up and down buttons. And I can, for example, move engrave up. So this means if I download this and I hit go, it's going to engrave first and then it's going to cut. But that's not all. Say, for instance, I wanted to, like I was unsure about the engrave. So I wanted to engrave, but then I wanted to stop before I cut it just to make sure the engrave was okay. Because engrave, for example, you might do it and then realize that, wait a minute, that wasn't quite dark enough. I want to do that pass again. So what you can do here is this column right here, which is partially obscured, is on, but I could shut the cut off. And then if I download, delete all, download to laser, and I had this design in here and I ran it, it would only do the engrave pass. It would not do the cut pass. So that would allow me, so if I knew everything was right, I could turn both of these on, upload it to laser, hit go, and it would do the engrave pass, and then it would do the cut pass, and then I'd be done. If I was unsure, again, I could just do this. I could download it to the laser like this, and if I hit go, it would just do the engrave pass. And then if I was totally happy with that, I could flip these, I could download it again, and then it would just do the cut pass. But notice, even though when I'm manipulating these, you might have wondered, well, what is the bounding box going to look like? Because if I just look at the engrave area, wouldn't that be a tiny bounding box? And wouldn't the cut area be a larger bounding box? So wouldn't it give me different origins with respect to this and different bounding box sizes? And the answer is no, it works properly when you're just turning on and off different layers with this. And the other neat little thing, like let's say you did this and you said, well, you know, I want to save this, but I know that I need to do the engrave pass twice. There's actually another column on the right, and you could actually go in and you can adjust the number of passes. So if I did this and then again hit download after I made this setting, it would run the engrave pass twice, and then run the cut pass once. One other thing that I will mention is we discussed the fact that the laser, when you hit go, will basically cut with respect to where the laser is right in that point in time. So if let's just for the fun of it, I'll move the laser origin to right down. So if you're looking at the laser right now, wherever the head was, and you download this file and you hit test to look at the bounding box, it would draw a bounding box to the left and up from where the laser is right now. So it's nice because you don't have to worry about positioning the piece somewhere specific on the bed, or even positioning the laser somewhere specific on the bed. You can usually just, wherever the laser is, as long as enough room around it, you take your piece, stick it under the laser, or you can move your laser closer to you if it's handier, and just hit go, and everything will happen relative to that. If for some reason you don't want to do that, like let's say, and I've only seen cases where somebody put a giant piece that filled the entire laser bed, or they were doing COVID production and they had this roller that was feeding the files into the exact piece. Sorry, feeding the material into the same place on the bed at the same time, and they wanted to cut it in the same place with respect to the bed every time. You can turn off this immediate button. And when immediate is turned off, that means it doesn't matter where the laser is when you hit start or where you hit the bounding box. It's going to jump to this point on the bed as shown, here, being a representation of the whole physical bed, and it's going to cut it there. So sometimes people get confused because this button right here, the LaserCut software will actually leave it set from the last person that checked it. So usually everybody leaves this thing checked, so they're always working relative to where the laser head is. But if the last guy unchecks this, what you'll see sometimes is you'll put your artwork in the bed, and then you will, let's say you expect it to be like 1 inch by 1 inch, and you have the laser somewhere, and you hit test and expect it to draw a 1 inch bounding box. The head goes all the way over to the other side of the um, so the laser goes all the way over the side of the bed and then draws a 1 inch by 1 inch bounding box over there. That basically means that you have this not in immediate mode, and it's going to use basically absolute positioning. I think this box would be better off called something like relative mode, because it means I'm always working relative to where the head right now is, and having this box not checked would be called absolute mode, which means I'm going to draw this guy on this bed exactly at the absolute position that it shows here. So, I mean, long story short, I'd say just leave immediate checked unless you need to do something special. And if you see it doing something bizarre with the head when you hit test, like it's jumping somewhere and then drawing the bounding box, it means you need to check this immediate button. So like I said before, if you really want to do something interesting, you're probably going to design it in another program, either a vector graphics program like Illustrator or Inkscape, or some sort of CAD program, and pull it in here, importing it as a DXF. But there will be times that you're either going to do something very simple and it's easier just to do it right in the software, or maybe you pulled some sort of artwork in and you want to do something like just draw some cutout boxes around them or something simple, and it's much easier to just do it right in here. So we're going to go through a little bit of the drawing features that LaserCut has and how you can use those. So the first one I'll show you, and I encourage you to follow along if you can run this at home, and you can also use the manual to refer to and figure some of the stuff out. It isn't really that unlike other things. There's a line tool. To use the line tool, you obviously select the line tool up here, click to start the line, click to end the line. Rectangle tool, click to start the rectangle, click to end the rectangle. Circle tool works the same way. There is also a polygon tool, and the polygon tool lets you draw polygons specifying multiple points. And notice that when I do this, if I put my cursor close to another point, I don't know if you can see really closely around the cursor, it turns like a green box around it. That green box means it's going to snap to where that point is. And if I double click, it's going to end that polygon. Again, just to reiterate what I said before, this tool up here, the pick tool, is the most important one, and it can do a couple important things. One is to click outside of everything, deselects. Click something, selects. Shift click something, and then something else and something else. Selects all those. Again, click out to deselect. If I click one or shift click this, and now I have two things. Again, this blue X is where I can drag around. If when I hover over it, it changes to that move thing. I'm Control Z here to undo. Again, I can grab one of these corners. Oops, that wasn't right. I got to, sorry. So notice when I grabbed, so this right here, it hovered as a move near that corner, but if I get right to the corner and I hover, that diagonal line is a resize. So I can resize completely unconstrained, or I can control click the resize to do it constrained. And again, what if I want to do it like exactly 50%? Well, you got to hit again over here, like we talked about before, the size tool, get your calculator out and start dividing these by 2 and re-entering the numbers. And that's the only way to do that, by a percentage or by some specific geometry. So line square. So the other thing is we have down here, we have a node tool, and allows us to edit the nodes. So if I select a geometry, like I can select, for instance, the polygon that I did, and if I go into the node tool, notice all the nodes that make up that polygon, they lit up with these little tiny yellow squares. And when I hover over one, I get a little move thing, and I can click and click, and then move those nodes around. The way it works is when you hover over it, you click and release, and then you can drag it and you're moving it, and then you click again to drop it back down. You also, if I use pick tool and select like this guy up here and go to edit node, I can also edit the nodes of something like a rectangle, even though I didn't draw it as a polygon. I just drew it as an initial rectangle. So a couple other things of interest. There are some things that deal with position and alignment, like, for example, I can select a bunch of stuff and these alignment things come on, so I can like left align everything, undo, right align everything, undo bottom, center vertical alignment, align middles, etc. This right here is an offset tool, and that's kind of cool because let's say I had, let me I'll erase this and I'll make like a weird polygon, for example, double click, and so that's closed. If I use this offset tool, I can say I can do like an inner or an outer, or auto or double outer or whatever, and I can give it a distance. So let's say I do outer offset 5 millimeter. It drew another box 5 millimeters on the outside of that one. So that's kind of neat. I can undo that. You can also obviously do an inner offset, and you can do the corners as arcs as well. So let's say if I do a 5 millimeter, I'll do, let's say for fun, I'll do a 10 millimeter inner polygon with a arc corner. So this little corner becomes an arc. That's kind of neat. That's something also, don't forget the laser has a little bit of a kerf when it cuts. So if you needed something to fit perfectly and you wanted to adjust for the kerf, you could use that as a method for doing that. Another important part is there is a copies, which is like an array tool. And so here's like something I usually do. If I'm going to cut something, let's say I have a piece of material, it's a new piece of material I haven't cut with before I even bring the design into the program, I might want to do some test cuts. So again, I might want to, again, pull up the wiki and get an advisory on what it thinks that the speed and power should be for this material. And let's say it was let's say I'm doing plywood RC aircraft 50-45. Say, okay, I'm doing 50-45, but that's just an advisory. So in reality, I don't know what the best way to cut it is. So you can try different kinds, or a few different values. So what I usually like to do is I usually like to draw a square, and I'll size the square to make it about a centimeter by centimeter. So I'm going to do a 10 by 10 size. And so that's tiny. I got to zoom in on that. But now I'll do a bunch of them. So I can use this copy tool, which is like an array tool, and I'm going to say, okay, I want, let's say, I don't know, let's say I'm going to go nuts. 3 rows, 3 columns, and a 3 millimeter gap between them. And I hit OK, and suddenly, ta-da, I get a 3 by 3 array. Now I could go, and let's say I want to do a bunch of different cuts. I could, again, start changing colors, blue and red and green, and then start applying different speeds and powers to each of these. And then, I might even want to save this so I can use this one file all the time. Then I hit go, and in one pass, I could try like 9 different speed and power variants and see what works best for that material. So that's something that this copies or array thing is good for. So the next part, this almost deserves its own little mini section, is text. So there's a few different things about text. So first off, I have nothing selected right now. Let's say I even had something. Let's say for fun, I'll draw a little arc here. Okay, but I'm going to deselect this arc, so I don't have anything selected. And if I use the text tool and I click and drag and let go, you always got to wait a second. I don't know why, but you have to wait. And then this box comes up. And obviously, the major things are the height, which is assumingly in millimeters. The font name, there's a bunch of different fonts you can use. I'm assuming this is just grabbing them all from the system. And you can type your text here, and then when you hit OK, ta-da, you get text generated of that. Needless to say, I can use the pick tool. I can move it. I could resize it if it was just horribly, missized and I didn't know what to do, to type in size-wise, etc. So that's kind of the default way that it's run. I'm going to erase all these. These are separate objects. But now if I have an object selected, like this circle, and I do that same thing, text tool, and then I'm going to drag and let go a box, it asks me because I have something selected. It's saying, along with selected curve, and usually you hit no if you just want to drop text down. But say I wanted to wrap the text around this curve, then yes, I could hit yes. And then it's going to give me the same dialog box, and I could type in the same things. And when I hit OK, it's going to do that. So needless to say, you could, I don't know, make your size your curve to the text or text to the curve or something to get what you want. Again, I don't really use this feature very much. If I'm going to do something funky with this, I'll go into a better program that lets me have better control over the text. So there's one other thing. So needless to say, like we talked before, this is the type of text you would engrave. And engraving, the head's moving back and forth, turning on when it's inside this geometry and off when it's outside, so it becomes dark. So these types of text elements is what you would use to engrave. Because if I were to cut this, if I were to cut along the cut path, it would actually cut a nice letter E out of the material. But since this isn't a stencil font, like it would happen with a stencil, this middle piece would fall away, and I'd basically wind up with a cut piece that would look like that, which generally is not what you want. But say, for instance, because engraving, especially if these letters are huge, is going to be very slow, and I wanted to just cut something around the geometry or something faster. There's another little neat feature that this has, which is called this SXH type. And if I use SXH, notice it doesn't let me use regular system fonts. It only lets me use, I don't even know what these are. Those fonts, no fonts, whatever. Anyways, if I hit OK, this is what it gives me. So notice, so this SXH, these are like stick fonts, and these are, there's no body to them, so I can't engrave them. There's no interior. Well, there is to an O, but they're just lines and they're sticks. And these are meant to actually cut rather than to engrave. And needless to say, if I did cut this, it would like drop out the center of the E or drop out of the center of the O. So one cool thing to do is if you had a lot of text to do and you didn't want to engrave the whole thing and take a lot of times, you can use an SHX font. You could turn the let's say the speed and power, this is what I was using to cut my material. I could do something like I could turn the speed up or maybe turn the power down a little bit so that these are basically going to act like a cut. It's going to follow the lines but not go all the way through the material. It's just going to mark the outside, and that's a nice, quick, easy way to get some nice text in there without spending a ton of time engraving big sections. I'll briefly mention that a lot of these buttons, so we talked about up and down as a way to reorder, to control ordering. Also, this stopwatch right here, if you click this, this is cool. It gives you an estimate of the work time. In this case, it's 3 seconds to do this job. Like I said, these fonts are very quick, and they're not. That's not a very big thing. Most of this stuff we don't use. This right here, X, Y, up and down, and the Z up and down, these basically mimic the keypad on the laser. Obviously, it's much easier to use it standing by the laser, pressing the buttons, than working on the computer. This is the Z0 button, or the focus. This is XY0. Laser on off power, I don't even know what that does, if it just pulses it or if it turns it on. I'd probably say don't press it. Run box, that is the same as the test button. Start, pause, and stop. Again, you can start the job remotely. And of course, download, again, download's really the important thing you're working with over here. That's downloading, deleting all, and then downloading current files in order to get them on the laser. An ECP is kind of like the native file that this guy works in. So when you're done, creating something and you might want to come back to it and use it again, you can go File, Save As, save it as an ECP file, and then you can just reopen it and it'll have all the settings applied. Now, since this is not on our laser and it doesn't have the software dongle on here, it won't let you save. But even in the wiki link that talks about installing this at home will tell you there's a weird little bug in it where is if you go to close, so it won't let you actually save. Save as doesn't work. But if I go to close the program, it says save changes to file, and I say yes, let me save those changes to file. I can now actually save that as as an ECP file, and that will actually work. And the neat thing about that is if there's mucking that you have to do in LaserCut, it's a lot easier. And stuff you're having trouble, getting the thing sized correctly and getting your DXF to import correctly, you're much better off doing that at home, working through all of that. When you're not in a rush in the lab, and then just bring the ECP file back to the lab, and it'll just open flawlessly and work on here. So that's basically all. One other thing that I will mention is, again, on the wiki, if you look under uh, Laser Rabbit, you will see under documentation there is a LaserCut 5.3 software manual. Please take a look at that. That'll probably go into a lot more detail on stuff that I didn't cover. And like I said, there are other training resources online right on our wiki on the engraved stuff that we go much further into, and using the rotary tool as well. I hope you enjoyed it. That's all for now.